All right, good people. So this is what we got. Day 32, quiz, which we'll do second, it sounds like. And then arithmetic sequence. It's a new topic. We're looking at the patterns of numbers. And this particular topic, once we do a little bit, is particularly important to finance. And so that's one that I really like there. Okay, so for today, this is the main formula that we're going to be using. And all of these strange new looking symbols have a meaning that I would like you to know. Okay, but for now, just copy down what the formula is so that it's there in your notes. And we'll go to the screen, figure out what each of these things are and how we can use it. Okay, so on the screen, what do we got? Well, a sequence, first of all, it's just a list of numbers, pattern of numbers in some way. For those first ones, we got 1, 2, 3, 4, just adding 1 each time, right? Nothing too fancy there. All right. This is another very well-known type pattern. Does anyone understand how, can figure out how this one works? You might have seen it in biology class. It's so popular. It's not the one that I made up. Yeah, what is it? Yeah. Yeah, see, that's how it works. Try and figure it out and go like, yeah, it works for some, but oh, not all. Try again. Oh, that's the magic one. So this happens in, this comes up in biology a lot with like rabbits and that sort of thing. Famous fellow, Fibonacci, Italian, came up with this, this pattern. And how it works is like this. Starts with a 1 and a 1. Actually, you tell me. How can we use this 1 and this 1 to get the next number? Okay, so we add them. So 1 plus 1 is 2. Okay. Then how do you get what's the next number? 3? Oh, yeah. See? 1 plus 2 gives 3. How do you get the next one? 3 plus 2 there. Exactly. You don't have to. Well, there's different ways that you can do it. Maybe in another pattern, right? But for this one, it's not like these two give that one. These two give that one. These two give that one. So it's almost like those go there. Those go there. Those go there. Something like that, you know? Yeah? Fibonacci, famous, right? Different than what we're looking at, but still interesting just the same. What we got here, arithmetic sequence. This is what we're looking at. Okay, so what happens is in an arithmetic sequence, to get from one number to the next one, you're always going to be adding or subtracting to get from one number to the next. And what you're always going to do is use the same number each time. This is what's special for an arithmetic sequence. Same number each time. Okay. This number that you add each time has that special name as it shows up on the screen there. Common, which is another word for same, and then difference. Okay, which I'll show in a second there. Importantly, that's going to have the letter D with it. What we got here? Oh yeah, a little baby example to start with. 1, 2, 3, 4, 5, right? Because how this works is starting with the number 1 there. What do you have to add in order to get to the 2? You add 1, right? For sure. What's the next number? Well, 2. What's the next number after 2? 3. What do you add? You see, plus 1 again, right? Same number each time. To get to the 4, same again. Add 1. Right? So because we're adding 1 all the time, this means we have an arithmetic sequence. And as I said, this is good for finance and stuff, for your future lives, planning your first house, first car, right? But importantly, the number we're adding each time means that D is going to equal 1. All right? Looking at this one here. What's the D value for this one? You got it. Yeah. From class, we got a good sounding answer. How do we get from a 2 to a 7? Yeah, exactly. Add 5. A cool, quick way to do it is to take this number minus that number. Okay? What's 7 minus 2? The number minus the number before it. You get 5, right? Okay. Same here. What do you got to add to get from 7 to 12?
5.
Yeah. 5 again, right? That's the point of this this demonstration here, this example. Right? And also, and 12 minus 7, that equals 5 again, right? Okay. So this goes on and on for this particular example here, plus another 5. So the common difference is going to be 5 for this particular, the second example here. Okay, the D is equal to 5. Okay. Can get a little more challenging now, just by throwing in some integers and stuff. What is the D going to be for this example? What do you add or subtract each time? You got a 6, a 2, you got a minus 2, a minus 6.
Minus 2.
I think Zoom might have got it. What did you say, Zoom?
Minus 2.
No, I still, unless it's my hearing.
No, not minus.
What you can do if you can't figure out, right? It is
Minus 4.
Minus 4.
Yeah, minus 4. Watch, you take one number and you subtract the number in front of it. Okay, so you got a 2, you're going to subtract 6, that's the number in front of it. What do you get?
4.
Yeah, minus 4, exactly. Okay, so that takes care of those two. We can try with the next ones. Minus 2, subtract 2 then. What does that give? Yeah, same, right? And just for fun, because it's just for the last one here. We got minus 6, subtract minus 2. Should give minus 4, but let's make sure. What happens with these minuses?
Become plus.
They come plus. So now I got -6 plus 2. Hopefully that's enough. -4 again, right? So the common difference for this example here is going to be -4.
Yeah.
Now, if you remember back from the formula, there's a whole bunch of other letters in there. So we got to take care of those as well. Okay. Some vocabulary there. Each of these things, they're called terms. The numbers that are in the sequence are called the terms. Okay, so what do we got? Yeah, just like this. Okay, 2 is the first term of our sequence there. 7 is the second term. 12 is the third. Now, this is where it gets a little mathy. We might have an n showing up, right? So instead of there being the first term or the second, we might just talk about some general random term there. Okay. So here on the camera, what do we got? We have this sequence of numbers here, right? So the number 6, this one, this is the first term, right? And so how are we going to write this with the symbols that we got? We're going to write it with A1. Okay. The 2, that's in the second location. That's the second term. So what's going to be the symbol for that one? Well, A2. Okay, that's how the stuff works. If we're looking at we can go off a little bit here. What will the 6th term look like? Using our list here, using our sequence. Go from 6 to a 2 to a -2, a -6. How much? I'm not sure. How much do we go by each time?
4.
4. So it's -4, that's right. So let's see. We have A1 is 6, A2 is 2. Could put that here. A1 is 6, A2 is 2. This is A3. That's A4. I just made it up. What's this question going to be? Or what's the value of it? Okay, so what's A5 first? No. How much do we go down by each time? Yeah, A5 is -10, right? Because subtract 4. And so to get to A6, you go one more time. What do we got? Hey, -14, right on. Okay, so the 6th term, the English is important with the symbols there, right? The 6th term is -14. Okay, now just like we have, X is an unknown, N can be an unknown. So on the camera there, or on the screen rather, they have AN. That's kind of like whatever, random term, right? Okay. This is the formula I showed you in the beginning. And it's a little bit of a shortcut for me just to give it to you, but I'll do that today because we have the quiz, and then tomorrow we'll talk about it a little more. All right, so taking a look at the formula that we got there, what does the A1 represent again? Yeah, for sure. A1 is going to be the first term of the of our sequence. Absolutely. First term. What is the D? Not bad. Couple of good answers. Number what? Number add each time. Okay, not bad. How about subtract, right? Yeah. Maybe subtract. They're kind of this, add and subtract are kind of the same. Yeah, importantly, each time though, right? Good. Someone from class said that it's A2 minus A1. Absolutely. You can take the second term minus the term in front of it, and that gives you what D is equal to. That's nice. It works for some other numbers as well, not just the first and the second. Also works for, see, third minus the second, all the way along. What's the name for it? Official name?
Common difference.
Hey, Zoom got it there. Common difference. Common means it's the same, and difference is the answer from subtracting. So if you subtract with these two terms or those two terms, the answer is always the same. Same answer from subtracting. That's what that means. Okay? And it, yeah, as it shows, AN is like the Y that we're looking for there. Oh, N, that's on our list there too. What is the N represent? We got A1, we got D. How about N? This might need some English with it. That is what? Oh, number that it doesn't give? Yeah, could be, but it's not always going to be N. It might
The
be other.
number, it's like the minus 4, what you said, the number we found by B and A.
No, number beside the number we're adding, no. Zoom, that wasn't clear today. I'm not sure if it's my ears or. That's better.
Yeah, I'm just tell you the number we find from the A and B, like.
Oh, I see. Yeah, not always. Same thing from Zoom, like the variable. If N was 1, what does that mean? What does A1 mean?
The first term.
First term, right there, right? What would A2 mean?
Second term.
Second, right. So all the way along. So what does AN mean?
First, but first, what I don't know.
So N on its own, I can help you out. This will be the location in the list. Location in the sequence.
Okay.
Okay, so AN, right, means the, or I'll put it like this. If we have N is equal to 1, that means we're looking at the first term. First location. If we're looking at N2, we're looking at the second location. Okay. Now, wouldn't be math class without a equation or formula, right? So what you're going to be asked to do is you're going to be given a pattern like this, and you're going to be asked to find the special formula for it. Now, the special formula has a couple of names that are up there on the screen. One of them is the general term, and the other is the explicit. That says formula instead. Okay, but general and explicit, same thing. Special formula for this particular sequence here. So taking a look there, we need to know what the first term is, because the first term is A1. And if you check that out, that's what's in the formula that we have there. So the first term on our list there is 2, right?
A2.
Yep. So the first one, looking on our, looking on the screen, the first number in the list is 2, right? So the first term is 2. Yeah. We don't need it for the formula, but what's the second term? What is A2 going to be? Yeah, A2 is 5. What's A3? 8, right? That's how that works. Okay. So we have A1, which we need, and we're going to leave in there. And we'll just keep as its own, like the X. Okay. The D. What's the D going to be? Yeah, for sure. Plus or minus. Yeah. And how do you know?
3. Because 2 minus 5.
Not necessarily. Yeah. There you go. What you do is you choose a number. So I'm going to choose 8 just because. And then what's the number in front of 8?
5.
Okay, so minus the number in front of it, right? And this will equal 3. So in other words, we have the third term minus the second term is equal to D. Okay, so D is equal to 3 now. Okay, so where does this get us? Because the goal is to create the formula for this particular sequence. We have A1 is A1 is 2. We're going to keep N, and D we figured out is 3 from what we just did. AN is going to stay as well. Okay. So in order to provide the answer, you just simplify this. Multiply it out, and then that's it. So what can we do to simplify this part here? Yeah, multiply. Oh, it won't be actually. Because watch, this is going to be 2 plus, okay? So this 2 is going to be added on after. The bracket and the 3 are multiplied together. Okay. Okay, let's just be careful then. So what we can do, yeah, we can put 3 in the front. So because things are multiplied, we can switch them around. So I'm going to put the 3 in the front, and then it looks a little normal, right? We've seen questions like that before. Now, importantly, with the orders of operations, you have to do multiplying first. So you don't go 2 plus 3 and then. That would be a bad day at the office. What you do is you multiply first. So that means we're going to get the 3 in, multiply the 3 with n minus 1, okay? So let's do that first. What do we get? One of these again. Remember that from a long time ago?
3x,
Did you?
3n,
What'd you call it?
3n minus 3.
It's not 2n though. What's that number? Oh, I see. Yeah, that's what it is. Yeah? Then that's okay. Good. So this part here, 3n minus 3, and then the 2 plus in the front. Yeah, if you said it, good work. I just didn't hear it. Nice. No, because it's not, it would have to be in brackets in order to do that. It, so when things are, maybe we'll show it like this. If you had if it was like this, then it'd be a little strange, but yeah, you do the usual, right? Okay. Now, officially, what you do is you add this first. 2 plus 3, 5. And then you multiply. Okay, but importantly, you need this bracket in order to start getting the full multiplying happen. No bracket means it's just the 3 only that gets multiplied. Okay, I think that's what you need to hear from this. Yeah. Okay. So the 2 is separate out in front. Dion, you saw that, right? Yep. So then you get this here. Okay. Only the 3 gets multiplied. One step further, what do you got? Final answer for the general formula, for the explicit formula, our general term. Yeah. I'll let you discuss it with your friends. You got this part, right? That was good. Yeah. Now work on the next part. Mm-hmm. Well, notice it's only 3n, right? So you can put that first. Then you're stuck, or you're faced with this. What's 2 minus 3 equal to now?
1.
Way easier. No, it's just minus 1. Yeah. So it's like, it's called, we called it this before, collecting like terms, right? So you look at the n's, that's the only n, right? Okay. These now are going to work together. They're going to combine. So you have 2 minus 3 now to look at. And we've done that something like that a few times, right? Yeah. Yeah, you're allowed as long as you keep the sign in front. Okay, so it's minus 3 that goes over there, right? So it's going to be 2 subtract 3. What do you get? Minus 1. What do you get? Final answer. That there is the general term or explicit formula. And what this allows us to do, watch, if we want the 50th term, not the first or the second term in the list, if we want the 50th term, we just put 50 in there and boom, it's done like that. It's fast. That's the benefit of it. Okay, I'll show you just to follow up on that. What is the 50th term of this sequence? All you do is you let n equal 50 and you work it out. As opposed to bouncing from one term to the other 50 times, right? So you want the 50th term. That's 3 times 50 minus 1, 149. Okay, would still be bouncing from 2 to 5 to 8, 11, right? 13. Would still be counting. Got the answer right there. Okay. See what's next. Same style. Same type of question. Negatives though, just to make life interesting. So if you don't mind, please, let's figure out what this general term is going to be. So we need to know what A1 is. N is going to stay. We need to know what D is. Yeah, that's it. Oh, and then the multiplying, algebra. So what does the A1 represent, good people? Minus,
-4.
no, it's the first term, so minus 23. A1 is the first, has a 1 down there, so the first term.
Yeah.
Yeah. What's D? Oh, that's what you're giving me. Zoom said the next answer already.
Yeah. Yes.
I don't
Minus.
know. 4 for sure, plus or minus, I'm not sure. Okay, well, let's check. How do you check? How do you check? You pick up a pen, you write it down.
23 minus 19 gives 4.
23. Oh, listen, Zoom said 23 minus 19. No, it's the other way around. You choose the one that's further on and then the one before it. You choose a number and subtract the one before it.
Oh, okay.
That order is important, okay? So,
Oh, yeah.
no. What you're
Yeah,
doing is
-4.
you have your list of numbers. You choose one of them and subtract the number that's in front of it.
Yeah, it's
So you
-4.
can't choose minus 23 because there's nothing in front of the minus 23. So let's choose another number. Yeah, we can do this one. Let's choose minus 19, right? And what number is in front of minus 19? See? So you subtract 23. That's what D is going to equal. Integer time. Subtracting a negative, what happens?
And the negative.
Subtract a negative, what happens?
It gives a plus.
Gets a plus, yeah. So plus 23 now. Oh, see? So now we know for sure that it's not only 4, but we know for sure that it is plus 4. So that's good. Okay. That's why I gave this question, just to make sure we got these integers worked out.
Okay.
So we can update the formula now a little bit. A1 plus n minus 1d. So that's going to become an is equal to, what's the first term there? Yeah, it's off my camera, but it's on off my camera, but on the screen. Minus 23 plus, we'll keep the n in there all the time for this general formula.
And 4.
Yeah, and 4, right on. Okay, so now I don't want to leave it like this. Go a little bit further to simplify this, right? So a little bit of multiplying and such. So
So
if you,
minus 24 and minus 23 plus and 4 minus 4.
not bad. Zoom said, I'm going to put it in quotations, all right? Zoom said minus 23 plus n4, okay? And then minus 4.
Not and 4 and
Yeah, that's why I put it in quotes. No problem there, Zoom. This is
yeah,
the order, like when it's written behind, right?
yeah.
But understand that this thing here, yeah, it's just 4 times, oops, 23, 4 and minus 4. Okay, make sure you got the number going first there.
Yeah, yeah.
Okay,
Okay. Thanks.
so not bad to think it, but be sure you write it that way. Now, okay, $1 million question. What's the final answer going to be? 4n, not 92. It's not multiplying. Minus 27? It is. Okay, it is minus 27. Okay, so that's our formula there, all right? That's the general simplified formula for this pattern.
Mhm.
Okay, as usual now, what is the 20th term going to be? Because we could go doing, 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 doing from one to the other, but no, we're smarter than that. Yep. So you just replace, you see how n now is replaced with 20? That's what we're doing. Let n equal 20, and then you work it out. So A20 is equal to 4 times 20 minus 27. And what's 4 times 20 equal to?
Wait.
Nice. 80. AT. Yeah, good. Subtracting 27, what do we get now?
There's 53.
I think so. I think I heard a 3 from Zoom. That part's okay.
53.
What do you mean, no, no, no? What the heck? If it's minus, this might be easy, or easier. If it's minus 27, right? Do minus 20 first. So what's 80 minus 20? Yeah, 60. And then another 7. See, you do it in 2 steps. Heart likes it. Right? So what's 60 minus 7?
53.
Exactly. Yeah. So do it in 2 steps. That might be nicer on the brain. Good and good for the heart. Okay, so done a couple examples there now. What's left? What's this? Find the 13th. Yeah, you know what? We're just kind of doing questions like this. Find the 20th term. Okay. So take a second and work out this one, please. What's the 13th term if this is the formula for it? Formula for some sequence. Notice it's not really simplified this one, right? That wasn't English. That was like French and English. The formula isn't simplified. So let's simplify it first. What do you get? 12 plus, yeah, we've seen this before, 3n, yeah, minus 3. And so you simplify, and what do you get? Yeah. 3n plus 9, good. Okay, so let's use this formula to get the answer. They want the 13th term now. What happens when n is equal to 13? Okay, let's figure it out. N is 13 now, plus 9 like that. So it's 3 times, what's next there? Good. What's the answer? No. Close. Yeah. Plus 9. Final answer. Thank you from the class. 48 there at the back. Right on. Good. I think there's one more. Yeah. Yeah. See? I think that's it. Yeah. Just that last one. Same style of question. Oh, already simplified. Don't know how that happened. Peter's trying it in his sleep. Let's see if he can do it. Don't worry, you'll be running around soon. It'll be all right. 21st term, okay. N is equal to 21. What number is in the 21st location? Oh, minus, right? Yeah. Right after this. See, we want the 21st term. So we let n be 21 now then, right? Okay, so some heavy lifting now. What are we gonna get?
Um, 105.
105, nice. That's for that part. Yep, Zoom got it.
Minus 11 plus 105.
Yeah, nice. Good. And so 2 steps again, right? 105 minus 11, so let's do 10 and 1. 105 minus 10. Final answer.
95, 94.
Zoom got it. What'd you get?
At 94?
Plus.
Yeah, plus.
No. No. Close. 94. Yeah. There we go. Plus 94 to finish it off there. Math is easy with glasses. It's 11 actually. You know what? You're right. That was a different thing. I was saying minus 10 and then 1 after for the 11. So yeah, 95, you'd be right. And then one more. 94. Final answer? Final answer. Okay. So this is the introduction to this topic here. I just want to point out, how many months are there in a year? 12. And so if you have 10 years, then how many months are you looking at?
Okay.
120, right? Okay. So what happens is when you buy a house, and this is an important thing that people do in their lives, then they pay it off for 10 years. And so you get every month, you get a payment, you get a number just like we were working with, right? And so how big is N going to be when you start looking at the money for houses? It starts being pretty big, right? 120. Do you want to bounce from term to term? No. You want a formula to get there fast, right? If you want 120, boom, you put 120 in there, and you know it right away. Okay, if you want to go for 20 years, that's double, 240. Do you want to bounce 240 times? No. Use the formula. Done. Okay, that's the benefit of it. Okay, a little brief introduction there. So for class, I do have a homework sheet for this, but we'll do it later on. Okay, that'll be for homework. What we'll do, take a couple of minutes, and then you got the quiz to do. 3 questions, 2 systems, and 1 line thing, just as promised. Okay. So I'm going to stop the camera.